Welcome back, friends. In this class we'll talk about the 2D motion, and before I jump into the 2D motion I'll start with the basics of 1D motion. So first of all we'll talk about what is the difference between 1D motion and 2D motion. So let's say if an object is moving along x-axis, so this is x-axis and this is y-axis. So there is a car which is moving along x-axis, moving east and then going in the west direction. That kind of a motion is called one-dimensional motion or 1D motion. And if the car is moving along y-axis, that will also be called one-dimensional motion. So if the object is moving along y-axis or along x-axis, that kind of a motion is called one-dimensional motion. Now let's take an example. If there is a car which is moving at an angle of 30 degrees with respect to the x-axis. So this is x-axis and this is moving at an angle of 30 degrees with respect to the x-axis towards the, and if I have to put it in right words, it will be 30 degrees north of east. So let's say the displacement of the car was 100 meter 30 degrees, delta D displacement of the car is 100 meters 30 degree north of east. So in this case I can see when the car is moving in this direction, not only it's covering certain displacement in x direction, it is also covering certain displacement in y direction. So let's say after 3 seconds the car is at this location, at this point, and so the car, how much distance covered? Let's say the car covered 4 meters in x direction and it ended up covering 3 meters in y direction. So this kind of a motion is called 2D motion. Now if I'm gonna make the situation a little complicated, if a car covers let's say 10 meters at an angle of 30 degrees with respect to east direction, so 10 meters 30 degrees north of east, that's the car's displacement, initial displacement, so delta D. And then car all of a sudden takes a let's say starts moving along the x-axis. So then the second displacement, delta D2, is equal to, let's say it is 20 meters at I can say 0 degrees north of east, or I can say in east direction rather than writing it like this. This is in east direction. So that is the displacement after it covers the 10 meters at an angle of 30 degrees north of east. It covers 20 meters in the east direction. I wanted to find the final displacement of the car with respect to the origin or with respect to the initial point. So this is what I wanted to find. What is the length of this vector? So in case of one-dimensional motion, if this was a one-dimensional motion question, the car covered certain distance, let's say 20 meters in x direction. Oops, I shall call it as 20 meters in east direction, and then 10 meters in the opposite direction, in the west direction. I wanted to find the net displacement, delta D. You would have said 20 east is positive, so I'm going to keep this sign as positive. I'll write it completely. So delta D equal to D1 plus D2, and then D1 is 20 meters in the east direction, so I'll keep it as positive, and then plus minus 10, which comes out to be 10 meters towards the east with respect to the original point, so 10 meters east. So you directly added these two values by keeping their signs into consideration, and then you solved it. but when it is a 2D vector situation like this, you can't directly add. This was 10, it looks like 6, so this is 10 meters, and this one was 20 meters. So how to solve this kind of a question? I can't directly add these two vectors. I can't say that 10 plus 20 or will be equal to 30. That would be wrong. Or neither I can apply the Pythagorean theorem. Why can't I apply the Pythagorean theorem on this one? What I'm gonna do, I'm gonna erase this and make some space. Why can't I apply the Pythagorean theorem on this one? Because this is not a right angle triangle. Notice you can only apply the Pythagorean theorem when it is a right angle triangle. Right angle triangle has one angle as 90 degrees. Now, how can I solve this kind of a question? So to solve this kind of a question, one of the method, the easiest method is the component method. So I'm going to apply component method. So in this component method, what we're gonna do, we will first of all look into the very first vector. So this is the first vector, which was 10 meters, and then I will try and find the components of this vector in x direction and y direction. So converting a 2D vector into two one-dimensional vectors. So this is 10 meter, this is 30 degrees. So I can find the x component. X component will be 10 cos of 30 degrees. And then y component will be, so I'm going to call it as delta dx, and then delta dy is equal to 10 sine of 30 degrees. 10 cos 30, if I calculate this value, 10 cos 30 will be 8.66, and this will be 5 meters. So car covered 8.66 meter in the x direction and 5 meters in the y direction. So I figured out these two components. Now then after that, car traveled only in east direction, covered 20 meters in east direction. So I'm going to draw another navigation system, and I'm going to draw 20 meters in the east direction. I'm going to change the colors now. So this is 20 meters in east direction. So now I wanted to find x and y component for this vector also. Delta dx, because it has covered 20 meters in east direction, so x direction, the distance covered in x direction is 20 meters, and delta dy value will be equal to, it will be equal to 0. And I can do it mathematically also. Here I'm going to put 20 cos of 0 degrees, and here I'm going to put 20 sine of 0 degrees. When you're going to calculate this value, this comes out to be 0, this comes out to be 20, because cos 0 is 1. And one of the things which I wanted to talk about, I'm diverting from the topic a little bit. This is very essential. So when the angle given to you is with respect to the vertical axis, let's say the angle is rather than this was 30 degrees given to us, rather than this angle, I've been given this angle as 60 degrees. So try and always change the angle with respect to the horizontal axis. That will make the question easy, but you can still solve it using this. But why I'm saying this, I'm gonna talk about this thing in detail in another video, but for the time being, I'll suggest you, whenever you are given the angle with respect to the vertical axis, try and change it with respect to the horizontal axis, so that you can always take horizontal component as cosine and the vertical component as sine. It helps you to make a symmetry. That's it. So I'm going to erase this. Now I have x and y components of the second vector also. So I'm going to find delta d net in x direction. is equal to delta d1 plus delta d2, sum of all the displacement. So there are only two displacements in x direction. One is 8.66 and this is positive. This is in the east direction. I have to mention the direction also. And we will consider north as positive, east as positive, west as negative, and south as negative. And this second is also 20 positive. So I'm going to add this. This comes out to be 28.66 meters. And we figured out this value. Now delta D in net in y direction. This will be equal to delta D1 y, I should write x here, plus delta D2 y. Again, this value is 5 meters. This is in north direction, so I'll keep it as positive. If this was in south direction, I would have taken this value as negative here. So 5, this I've kept it as 5 positive. If this was north, this value would have been negative. So 5 plus 0 is equal to 5 meters. Now I figured out the x and y components. So I'm going to go to another slide. Oops, I'm going to go to this slide and try and finish this question here. Erase this portion. So let's draw both the displacements again on the navigation system. So in the horizontal direction, net displacement delta dx was 28.66 meters, and in the y direction it was only 5 meters. Now I wanted to find the resultant value. A lot of times we make a mistake. What we do is, if this is in y direction, this is in x direction, we join the resultant like this. That will be wrong. You cannot add vectors like this. All right. So if this vector is pointing outwards from the origin point and this vector is also pointing outwards from the origin point, your resultant vector will also be outwards from the origin point. What you're going to do is, you will replace this 5 meter from here to, you will take this 5 meter. I'll try to do it using my pen. So you will move it from here to here. All right, that's how you will try and do it. I'm gonna keep this line here as it is, and then I'll try to erase this. Now it looks better. So this is 5 meter and this is 28.66, and I wanted to find this value. Now because there is a right angle triangle, I can apply the Pythagorean theorem. So delta D value will be equal to, this is delta D net. Delta D net is equal to delta D net in x direction square, this square, delta D net in y direction square. So that's going to give you 28.66 square plus 5 square. That will give you the answer. So 28.66 square plus 5 square, square root answer, which is 29 delta D net. That's what our answer will be. So hopefully you were able to learn something about how to add 2D vectors by component method. So this is one of the methods. There are other methods also, but I'm gonna stick to this method for the timing to solve the questions because students like this method the most. So thanks for watching. Have a good day. Bye.